Welcome back, everybody. This is going to be part 3 of 5 in my lecture series on functions. If you haven't seen the first 2, please go watch them now. In this video, we're going to talk about what it means for a function to be increasing, decreasing, and constant. Let's get started. At first glance on this screen, you can probably already see our function notation coming up. Let's suppose f is some function on an interval I, and suppose x1 and x2 are two numbers in that interval so that x1 is the smaller one. We say that f is increasing if x2 gives the higher function value. We say it's decreasing if the bigger input gives a smaller function value, and we say it's constant if the bigger input gives the same function value. This is a really difficult definition to digest because it's got a lot of math symbols floating around and stuff like that, but they describe some pretty simple ideas. And I think it's easier to see what these words mean with a picture. For example, an increasing function, remember that tells me if I have two inputs, let's say I've got x2 over here. Let's say I've got x2 over here and x1 over here, right? This is an example where my input x2 is larger than my input x1. All this is saying is that the function value for x2 should be the bigger number. So maybe that looks something like this. And maybe it's doing something in between, like this. All increasing means is as you look left to right, it gets bigger. So you can probably guess what a decreasing function looks like. Like that. Something where as you look left to right, it gets smaller. And a constant function is something where if you look left to right, it stays the same. Now, why do we care about increasing and decreasing? Mainly for these definitions. A relative minimum happens at a point A, where if on some open interval around A is the smallest point. And we say the same thing for a relative maximum. As long as there's some interval around A for which A is the biggest point, or the largest function value, we call that a relative maximum. Let's take a look at this example. Here, I would say that this point is a relative maximum. Because notice I can take some interval, if I follow this point down to the x-axis here, I can find some interval around it so that for all the points in this interval, and again, if I map those back up to the function, the orange point, or the maximum, is the biggest one. That said, here right around 2 would also be a relative minimum, because I can take some interval, and it doesn't have to be the same size on both sides. And when I map that back up to the function, I get that this orange point is the smallest point in that interval. So a relative maximum is the biggest point around, and a relative minimum is the smallest point around. That's going to wrap it up for this video. I hope that you're taking away how to identify relative maxes and mins, and how to identify whether a function is increasing, decreasing, or constant. In the next video, we're going to look at symmetry in functions. Catch y'all in the next one.